So let's take example like if there's a spring is there, spring constant K, that one. So there's the end A, there's the end B. Now what I do is like the end A got displaced. Both the ends of the spring, I'll pull it up. So the displacement of end B is XB, the displacement of end A is XA. Now he's asking, what about the total elongation? The total elongation, this is the natural length of the spring. This you call L naught. So now tell me like how much spring got elongated? XA plus XB, no? Are able to make it out? So this NB elongated by XB and A elongated by XA. What is the total elongation of spring? Total elongation of spring is X is equal to XA plus XB. Then how much of spring force? You have to show spring force acting as like this, KX and KX. Don't write KXB, KXA. What is the total elongation of spring? Is XA plus XB. So why XA plus XB? You know from here only directly what is the increase in length. This end I'll move by 1 centimeter, this 2 centimeter. What is the total increase in length? 3 centimeters. So what is the total elongation of spring? 3 centimeters. So how much of spring force? Total elongation into spring constant will be spring force. As it is elongated, our spring force should act at the ends directed towards center. Similarly, I will compress the spring. Then this end is compressed by a distance XA. This end is compressed by distance XB. Then what is the total elongation? Again, the same thing. So the total elongation is X equal to XA plus XB. Then what about the spring force? The spring force now total elongation is X, no? So how the spring force? Spring force will act away. You can show anywhere. So let me show at the ends. Got this? So if the both ends are moved opposite, then what is the elongation or compression will be sum of the displacement of the ends. Okay, now there's the first case. You see now a situation arises for you of like this. Compared to this, so end A. Okay, now I'll make the end A to undergo displacement. Even the end B undergone displacement. Look at now, the displacement of this is towards right. The displacement of this end is also towards right. Now, if I put XB greater than XA, now what is the state of spring? Both the ends have displacement in same direction. Then what is the net displacement if XB greater than XA? Is it elongation or compression? You should tell me. Like it's very easy, no? This will be 3 centimeters. XB let it be 3 centimeter, XA 1 centimeter. So length of spring increase or decrease? It increased. So it got elongated. So therefore, how the spring force I have to show? The spring force should be Kx like that. Then what is the value of X? The value of X should be XB minus XA. It happens that both the ends will have displacement in same direction. Then is it a compression or elongation? Who will tell? You have to look at the situation here. So this is at natural length spring. Then what is the state of spring? This is elongated. Similarly, the first case A, case B, I'll put it. If XA greater than XB, You can see clearly here now, XA is greater than XB, no? So what is the state of what is the state of spring? The spring here, it got compressed here. The B is having more displacement than it. So what is the state of spring? Spring got compressed here. So compressed in the sense how the spring force should act away like this. So here I'll show it, so that will be visible for you clearly. Got the idea, no? So here both the hands will have displacement. Then is it elongation or compression? I think we have to look at the situation. Just not like where spring means always elongated. Spring means always compressed. No, look at that one. And now if similarly, both are having displacement in same direction. So here I think from looking at the diagram, now third situation, if XB equal to, I think this will be quite easy, no, to really assess the thing. And how is the displacement? The displacement of both the springs are away from each other at both the ends. So what is the state of spring now? It got elongated, no? So what is the state of spring? Elongated. What is the state of spring? Compressed here. Now what is the elongation now? Anything XA greater than XB, XB that one. So total elongation should be XA plus XB. Then how the spring force should act? Spring force should act in this direction. I think this when both the ends are having displacement in same direction. Here, what is the thing? For these two cases, what happened? Both the ends are displaced in same direction. Here, what happened? Both are displaced in opposite direction. Okay, let's last one more case. Option D, this one. So here, what I do, I'll compress the spring. So this is the XA. And this is the position of A and B. So both the ends, it got compressed, no? XA and this is XB. Now, what is the state of spring now? So it is said to be compressed. Again, what is the elongation? What is the compression? You have to write XA plus XB. Then how the spring forces you will show. So it will be in this direction. Okay, got this. So this is the thing. So now what you can comment? Both the ends are displaced in opposite direction. Then this the condition is what you have to follow. Okay, got the idea. So this about the so what we have to do is like we have to check it. Is it both the ends of the spring are getting displaced or only one end? So another situation we do come across like this. I'll show it here. So D. Okay, we'll take the next condition. The situation is one end of the spring is fixed to the wall. This is the natural length. Then what I do is I will pull one end. You look at the point P. So what is the displacement of the other end? It's zero, no? So which end got displaced? The right end. So what is the displacement? Let it be x. Then how much of spring force? The spring force will be kx. You have to show that force acting here also. Of course, this force cannot displace the wall, but there will be force exerted by the spring on the